Well, welcome to Wednesday, everybody, as we're continuing our study in functions and learning about modeling and predicting change because the only thing constant in life is change. All right, so last time we met, we were looking at what is slope. And so, just by way of reminding ourselves what slope is slope describes the steepness of a line, and slope is the change in y over the change in x. And we learned also that slope is rise over run. So those are the things we already know about slope, in addition to the fact that slope is the m value of your linear function. Over here, the y equals mx plus b, or f of x equals mx plus b. That m value there in the function is the slope. So here's how we today are going to find the slope from 2 points. The first thing you're going to do is label the x and y coordinates. Then you're going to find the difference. So DIFF ERENCE of y, and the difference DIFF ERENCE of x by subtracting. Okay, and then we're going to write slope as the change of y over the change of x. All right, so here we're going to learn what we call the slope formula. And this is another one of those things that is going to be with you the rest of your math career. And so here is how the slope formula is written. It's going to be m equals, and we get m because it's the m value of your linear function over there, y2 minus y1 over x2 minus x1. Okay, so that is the slope formula. All right, so let's go ahead and look at how we can use the slope formula to find the slope of a line when we only know 2 points. So if we come over here, let's suppose we have the points 4, 7, and the other point of 8, 10. And we are going to find the slope of the line. Okay, so what we're going to do is we're going to use the slope formula. So if you remember our steps over there, we're first going to label our x and our y. So there's x1 and y1. Then we have x2 and y2. So then I'm going to take my slope formula and simply substitute these values into the formula by finding the difference in y and the difference in x by subtracting. And then I'm going to leave slope in that ratio of change in y over change in x. So slope equals y2, which is 10, minus y1, which is 7, divided by x2, which is 8, minus x1, which is 4. So 10 minus 7 is 3, and then 8 minus 4 is 4. So my slope for this particular line is 3/4, or it's a rise of 3 and a run of 4. Now, as you're using this slope formula, it ought to look rather familiar to you because we did use something earlier this year very similar to it called the distance formula. And the distance formula was x2 minus x1 squared plus y2 minus y1 squared. And we found the square root of all of that. We also had the midpoint formula, which was x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay? And you'll notice the similarity in the three of these formulas, and that's because the distance formula and the midpoint formula are both derived from the slope formula. So hopefully later on this year, I can show you how we take the slope formula and the Pythagorean theorem, and from both of those, we can create the distance formula. Okay, so let's go to another example. And let's say in this one, I have the points negative 2, 1, and the point 2, 2. And again, I'm going to find the slope of the line. All right, so we start off, we label x1, y1, x2, and y2. All right, so I use my slope formula to find the difference in y and the difference in x by subtracting. And then x2. All right, so here you want to remember that anytime you have negative and a negative, that becomes a positive. So my slope for this line is 1 over 4, or 1/4, a rise of 1 and a run of 4. Okay, so let's do one more example, and then we'll go to some graphs, and I'll show you how you can use this when you have a graph of a line. All right, so if I have 4, negative 2, and 3, negative 2, and I want to find the slope of the line. So I label, then I'm going to find my difference in y and my difference in x by subtracting. So negative 2, and this becomes plus 2. So negative 2 plus 2 gives me 0 over negative 1. So 0 divided by anything is 0. So my slope here is m equals 0. And I would say this is a zero slope line. So if you remember what we've already studied, a zero slope line is just a horizontal line. So anytime you have 0 in the numerator, it's going to be a zero slope line. Now, let's suppose I had negative 1 over 0. Can I do this kind of division? No, I cannot. So this is going to be an undefined slope. Okay, so 0 in my numerator over here is a zero slope line. 0 in my denominator is an undefined slope. All right, make note of that because you might see something like that in your assignment that you're going to do after this. All right, so let's suppose over here I have a line and there's 2 points on the line. I have up here 1, 6. And then I have over here 5, 2. So I'm trying to find the slope of the line between these 2 points. So what I first need to do is just follow the steps that I already gave you, is to label x1 and y1. And it doesn't matter which set you label as x1 and y1 and x2 and y2. Because of the way the slope formula works, it's going to come out the same either way. So So my y2 is 6 minus the y1, which is 2, over x2, which is going to be 1, minus x1, which is 5. So 6 minus 2 is 4. And then 1 minus 5 is negative 4. So 4 over negative 4 is going to simplify to just a slope of m equals negative 1. And that should make sense to you because this line is decreasing from left to right. And when a line is decreasing from left to right, it is a negative slope. So let's go over to this one. So here I have, again, negative 2, 0. And then up here I've got 6, 3. So again, I'm going to do the same thing as I'm going to label the points. So here's x1, y1, x2, y2. And I'm simply going to find the slope of this line. So we'll take our slope formula. All right. So y2 is going to be 3 minus 0. That's y1. And then x2, which is 6, minus the negative 2. So 3 minus 0 is going to be 3. 6, negative, and a negative makes a positive. So it's going to be 8. So here my slope is 3/8, or a rise of 3 and a run of 8. All right then, so for today, please watch this next video I've gotten here called Calculating Slope for an Airplane Descending. It's only 4 minutes long. It's really good about how slope is used in flying airplanes. Then once you have finished with the videos, complete the maze as we continue our amazing week in math. Okay, another maze for this amazing week. All right, pay attention to this other line here about the progress check on Friday. And here is your maze for the day as we continue our amazing week of math. All right, so start at the start, solve the problems, and find your way to the finish. Okay, everybody, have a great day. I will not be on Google Meet, but you can email me if you have any questions.